everyone. Welcome to this edition of the Quantum Experience. I'm delighted to be joined today by Johannes Jobst. He is the CEO at QuantaMap. Johannes, thank you very much for joining me today. It's good to have you on.
Thank you for having me.
Cool. This for everyone at home. This edition has been about 2 months in the making. Yeah. Johannes has been on the road a lot recently, so yeah. Tell us what you've been up to and tell us a little bit about your background. That would be a good place to start.
Sure. Now, so we are at the moment really growing quite a bit at QuantaMap, and there were a couple of important conferences and project kickoffs, which indeed kept me busy the last weeks. But now we just moved offices this morning, so a lot of stuff coming together, but it's exciting. Yes, so I'm Johannes. I am a physicist by training, have been working in multiple fields, did a PhD in Germany, so I'm German originally, and did a PhD there on quantum matter and quantum transport, and then moved on to Leiden as a researcher and postdoc doing something completely different, namely electron microscopy. And then worked on big engineering projects in a R&D firm, mainly for projects for the semiconductor market. And then about 2 years ago we started QuantaMap together with people that I know from Leiden. And it's been exciting ever since.
Yeah, great. It's been I'm really excited that you've decided to join us because it's something that's slightly different to the norm, and it's good for people to hear about the different things going on. So tell us about QuantaMap. What are you up to?
With QuantaMap, we're really enabling quantum technology more broadly, and we're explicitly targeting one of what we think is the major bottlenecks towards scaling quantum computation, and that is that making quantum chips is just really, really hard. And that is because the qubits intrinsically are very fragile, so they are disturbed by very, very subtle defects. And all the manufacturers of qubit chips, they're making progress, getting the quality higher and higher. But it's just a really, really hard problem to solve. And what we do at QuantaMap is we develop and sell a microscope or a microscope system tool specifically for that problem. So what we do is we take images of the quantum chip in a very specific way. We can go into that in a sec. But that is so sensitive that we can detect the defects that matter for those qubits, and that way we can help the producers of the qubits to sort of close the feedback loop on their production, which really helps them making the chips better faster. And in the end, that's what it's about, right? It's about making the chips better, going into some sort of Moore's law type of scaling, and having a high enough reproducibility and yield in chip production to actually being able to do that. And that's our mission.
So what was your first exposure to quantum physics or quantum technologies?
For me, I think it came relatively late. I mean, we did a bit of quantum physics in high school, but there it never, I don't know, really resonated. It just was one of those historic experiments. And then I really got excited when I did it during my master degree, where we went really pretty deep, and then it was mainly theoretical. And I really liked solving these integrals and all this like different way of looking at physics and at the world. And that I found very exciting and nice. But I think I only really understood things during my PhD. During studies, it was really more of a like math riddle type of thing.
Yeah.
Complicated riddle, and you can solve equations and then you can make predictions, and it's all very nice. But during my PhD, I really started doing experiments and trying to use the theory to explain the experiments. And for that, you have to really develop to some degree an intuition for these quantum effects, which is not always so easy because a lot of it is counterintuitive. So I think it takes a while of getting used to it. And that I think took a good part of my PhD also, to really feel confident with this.
Yeah.
Um, and yeah, I think that combination of sort of theoretical underpinning from the studies with a much more applied intuitive understanding is what I also enjoy the most in my work in general.
Yeah, I've had a few of these conversations for the series and just in general in my day job, but people often talk about that struggle to understand things, and I feel like understanding is not really a binary word. You know, it's not that you either understand something or you don't. It's
Indeed, indeed.
you know, it's sometimes it feels like you go over a hurdle and then the road is much longer than you think it is. You know,
There is this very famous trajectory that you go through, right? In the beginning, you know nothing. Then you go through a stage where you think you know everything, but you actually have no clue. And then you
yeah,
go down again the valley where you're like, okay, I start to understand things, but I also understand how little I actually understand. And yes, I think for something that's sort of as weird as quantum physics, it just takes relatively long to go through this progression. And I'm not sure if I went out of this dip truly.
yeah. I mean, it's sort of Dunning-Kruger that's very most exposing, but so, are there any mistakes that you've made during your career that was a pretty major learning experience for you?
No, plenty. I mean, if you don't make mistakes, you don't learn. Um, no, and to yeah, maybe I guess sort of funny one during my master project, because that might resonate also with the good part of your audience. Um, we I did a master project and then also PhD actually on graphene, so two-dimensional material, which back in the days when I studied was really hot. Like there were very few people who were doing this at that time, and everything was unknown, sort of. That was very exciting, and we did a lot of measurements in a cryostat to understand the temperature behavior of the conductance. And yeah, basically I took a lot of data, and then when writing it up for the master project or master thesis, um, it became more and more apparent that it doesn't all really fit together so well. And then I decided to just write down the observations and write down what the potential conclusion is, or different hypotheses. And one of them was that it's just all stemming from contamination somewhere. And then, in fact, sort of in the first week or two of my PhD, we decided to give the cryostat a really thorough cleaning with some nasty acids and stuff, and that just completely changed the results of my whole master thesis. And that was really a very important learning experience. That it's important to look at the data early, um, write down the hypotheses that you have, and then see what the impact is and try to check them off one by one. And yeah, I think that really helped me in my PhD time, then also to be very critical with data and try to do this feedback loop faster. Um, yeah, I think that was a pretty important one. And then somewhat later in my postdoc times, I was working on a main topic, electron microscopy, but I had sort of half committed to some other project topic that I spent, in a sense, too much time on. I should have much faster realized, okay, this is extremely low probability of success, a really long journey, and probably not worth the pain. And yeah, that's what I'm now trying to do sort of on a daily basis to really evaluate, okay, is what we're doing getting us in the right direction, or is it a too risky path? Is it really worth the effort? And yeah, trying to take those learnings of fast iteration, fast feedback. Yeah, those were really quite important for me from a technical uh, growing up perspective.
Yeah, I mean, I guess now in your position as CEO, where you're leading people, I guess those learnings are still applicable to your current position in a sort of different sense.
Yes, no, they are right, and I'm of course mainly like over time the team and the responsibility and everything has been growing. In the beginning, in my master project, I was basically alone, or like we were two people doing it at the same time, which was actually very nice. And then already during my PhD, the team became really big, so I had a lot of students to supervise. And yeah, now I also again start growing the team, and then a lot of the decisions that I'm making are not things that I'm actually then executing and doing.
Yeah.
And therefore, I think it's even more important to, on a relatively high level, because I cannot know all the details, obviously, right? For that, I have a team. On very high level, try to always ask the question like, okay, is this bringing us in the right direction? Should we not be doing something else? And yes, I think this learning experience is very, very applicable, not only to one's own technical work, but much broader for any project with pretty much any team size that we're working on.
Yeah. It's funny how little mistakes like that you did years ago scale up and you're still learning from it in a different way. It's
And
interesting.
the important thing is to also realize that those was a mistake in a sense, right? It was a
Yeah.
non-ideal approach, and then reflect on that and try to do something and grow with it, because otherwise you just struggle on in the same sort of way all the time. And yeah, that at some point, at a relatively moderate team size, this starts to break. Right, and that in a
Yeah.
sense also makes a big difference with people. Some people are just really, they like the technical thing, they want to do their own specialty, and that's amazing, right? We all need those type of people, and in the end, they really drive a lot of the innovation. But then some other people also really need to say, okay, I have done all this, I took my learnings from it, and I don't need to go into all the dirty details, and then can look at it from somewhat further away, maybe.
Yeah. No, that's great. Do you know, I was reading, just to go back about 2, 3 minutes, I was reading about graphene maybe about 2, 3 years ago. And it mentions, I can't remember the details, so you may know about this, but I think it was either first discovered or they discovered they could create a 2D material with sellotape.
Yes, yes. Yeah,
Oh, wow.
that is another learning maybe from from doing science and doing technical developments. For a very long time in the development, it doesn't have to be perfect. It has to work, and that's extremely important. And you can get pretty far with that. And I think graphene is a fantastic example, right? They took natural graphite that you can just buy, nothing special. Later, they even show you can take it out of like a stroke of a pencil. And then you take Scotch tape and you just peel it off often enough, and at some point you're left with a single atomic layer of carbon. This is unbelievable, right?
Yeah.
And
Wow.
it comes from a very simple principle. They just looked at, okay, what's the adhesion force between individual carbon sheets, and what's the adhesion force of Scotch tape? And then you realize, okay, the Scotch tape adhesion is actually stronger. So if I do this, in theory, this must work. And then it's just a question of probability and sort of endurance to find
Yeah.
this. And I think this is fantastic. And then on the other hand, this is obviously really not scalable,
Yeah.
and a pain in the neck to do, right? I during my PhD, I actually did a somewhat more industrial compatible way of growing graphene on a wafer. But then later, I went back to the Scotch tape stuff because the quality of the material is just really extremely good. But yeah, it clearly doesn't scale, and that's the other learning, in a sense, that you get very far with this hacky approach, but the work that you need to do to get it from this hacky approach to something that is reliable and actually scales is way longer than you think.
Wow.
And so and in a sense, that's where we are currently also with QuantaMap, right? We
Yeah.
build a prototype, we know it works, we have first customers, so it's all great. But if to bring it to a stage where this really can go into a production fab that is really producing quantum chips at volume, so it's a bit
Yeah.
similar to a semiconductor fab looks, which is sort of more my recent technical background. There is still a lot of work that needs to be done, and that's a journey we're on at the moment.
Oh, great. Well, we're actually looking for sponsors for this series. So if Scotch Tape want to get in touch, I'm more than happy to cut a deal with you. Okay.
As far as I know, it's really that brand that everyone uses, actually. It's very funny because it needs to be very clean, right? Otherwise, you leave all this sticky residue.
Yeah. Okay.